So some examples of working through derivatives of inverse functions. So here we have the function x to the fifth plus 2x minus 1. I'm letting you know that 1, 2 is on the graph, which it is. If you plug 1 in for x, you do get that f of 1 is 2. And two things I'm going to ask here. I want the derivative of the inverse when x is 2. And then I want to write the equation of the tangent line for f inverse when x is 2. So if I kind of think of it as, well, f of 1 is equal to 2, that means f inverse of 2 will equal 1. So this is going to be the same as 1 over the f dx, or I'm sorry, let me go with 1 over f prime of f inverse of 2. So kind of doing it the first way I showed in the last video. Because this is asking, this new Leibniz notation makes it much nicer when we're using the inverse function notation here. So this is going to be 1 over f prime, and f inverse of 2 is 1. So I need f prime of 1, so f prime of x is equal to 5x to the fourth plus 2. When I plug 1 into that, I get 5 plus 2, which is 7. So I get that the derivative of the inverse when its x is 2 is 1/7. Well, then, to write the equation of a tangent line, I need two things because it's a line. Since it's a line, I'm going to use point-slope form, which means I need to have point and I need a slope. So for the point, I'm told the x is 2, but I found over here that the y-coordinate for that is 1. Oops, wrong color. And then for the slope, well, that's the derivative, which I already calculated, is 1/7. So my tangent line is going to be y minus 1 equals 1/7 times the quantity x minus 2. And there's the equation of the tangent. That's one way that you could see this asked. The other way is with our table of values, which everybody always seems to find oh so lovely. So we have g, we have f prime, we have g prime, and we're being told that g inverse is the inverse of g, and to find the equation of the tangent line for g inverse of x at x equals 2. So I'm going to approach it the second way from my last video, where I'm going to think of it more in terms of coordinates rather than function notation. So to find the equation of a tangent line, I need a point and a slope. I'm going to focus on the point first. So g inverse of 2, I'm not sure what that is yet. But that means that g of something has to equal 2. So this is where I go to my chart. Okay, here's g of x equal to 2. So the x is 1. So if that's a 1, that means that 1 is also going right here. So I have the point 2, 1 is on g inverse. And this means that the point 1, 2 is on g. So now for the slope, g inverse prime of something is going to be 1 over g prime of something. Well, I'm told to use an x of 2 for the inverse, but 2 is not the x coordinate on g. That's going to be the 1. So I need g prime of 1, which, looking at my chart, whoops, is 5. So my slope is 1/5. So then my tangent line is going to be y minus 1 equals 1/5 times the quantity x minus 2. and there's my tangent.